Hi, hello, namaste. How are you all? How is the energy? Let's start today's session with a beautiful affirmation. What's today's affirmation? My body is my best friend. It supports me every day and I do support it. What? My body is my best friend. It supports me every day and I do support it. So how can we support it? Just by becoming health conscious, self-awareness, right? And also the second one, I'm learning to express my feelings openly and peacefully. I'm learning to express my feelings openly and peacefully. So let's start today's session. So what I'm going to do in today's video, so I'm going to take up the second year computer science model question paper 2 and the complete solution for it. Okay, so complete solution will be there. It's a model paper released by the PU board. So let's start the session. So let's start today's session, that is going to be second PUC computer science model question paper 2, which is released by the PU board. Okay, complete solution will be there in this session. So the first MCQs is like this: given Q is equals to N by D, if D is equals to 0 and N is equals to 50, which built-in exception occurs? Very simple. So what is the question? The expression they have given as N by D, and if the value of D is equals to 0, anything divided by 0. What is anything divided by 0? It's definitely going to give an error as zero division error. Zero division error. So we'll go to the next question. The function which returns an integer that specifies the current position of the file object. Okay, the file object, whenever you open a function, I told you that it's going to return a file object. The file object, you want to take it wherever you want it, means that's going to be, you want to take the file pointer wherever you want it according to your desired position. That's going to be seek. But the question here they've given is that specify the current position. Exactly tell me where exactly the current, where exactly the file object is present. That's going to be tell. That's going to be tell. So answer is going to be tell. Clear? Not seek. We'll go to the next question. Stack data structure is used in accessing link of the last visited web pages. And the reason is the ordering principle is going to be FIFO, first in, first out. So stack is going to be used in accessing the last visiting web pages. Definitely yes, if you watched, I have told you many times also, you have watched YouTube and then Netflix and then Google. Means which is the recently visited web page? Google only, no? So first, what I told you, it's going to be YouTube, and then we have Netflix. Okay, then we have Google. That means last in, first out. So this is going to be true. What about this? The ordering principle of stack is what? It's going to be LIFO, no, not FIFO. So this is going to be false. So one is true and this reason is going to be false there. So the answer is B. So A is true and R is not the correct reason. R is not the correct reason. So we'll go to the next question now. So next question is arrangement of linear data structure in which addition and removal of elements can happen from any end. Okay, it's a linear data structure, so it can be stack or queue. What they are telling, okay, I can remove an element and delete an element from both the end. Both the end means, just remember, it's going to be Deque. It's going to be Deque. Okay, space should be there here. It's going to be Deque as an answer for this question. Deque is the answer. Okay, so changing the position of two elements with each other means, for example, there is an A here and there is an B here. 10 is stored in A and 20 is stored in 20. B is stored in 20. Okay, 10 have stored in A and 20 have stored in B. I have to change the values, what they have given. Changing the position of two elements in which, okay, so with each other means what? This is going to be swapping. Very simple. A comma B is equals to B comma A. So this is nothing but swapping only. Clear? We'll go to the sixth question. The nested loop will have the time complexity as the nested loop, a loop within a loop, so many sorting techniques, or it can be with respect to a pattern also, and loop within a loop is called as nested loop. A nested loop will have a time complexity as n square. It's going to be n square. We'll go to the next question. The next question is identify the DBMS software, database management system software. So here the answer is going to be Microsoft Access. These are all not the DBMS software. Microsoft Access is the DBMS software. We'll go to the next question. The symbol used to represent the intersection operation. It's going to be very simple. You've also learned in maths. Sets, under sets it will come. That is going to be this symbol, intersection symbol. Okay, we'll go for the next question. Which data type is used to hold numbers with decimal points in MySQL? For example, I just want to store the percentage as 89.956. Ma'am, why 89? You could have taken 90 only. No, yes, nobody wants to get that 89, 59, 69. No. If you get, you give me a round of number, not like this 89 or 69, isn't it? So what is 89.956? I just wanted to store this, so it is not possible for me to store with any of these data type. We have to use a float only for storing the decimal point. Numbers with the decimal point means float only you have to use. Okay, we'll go to the next question. The clause, sorry, it's not the cause, it's going to be the clause. I'm not able to read properly. The clause used to enforce condition is what? For example, there is a statement here, select star from table name, select star from student. So I just want to know who are all watching the video. Let's consider. Okay, who are all watching the video? I just wanted to know all the details of the students who are watching this video. Select star from student. Okay, this is going to be all the student details. I'll get to know about it. I just want to know a particular student watching at this time. So which are all the students watched at right now at particular time? That means the condition should be given using what? Using a where clause. Condition should be given using where clause. Okay, where? Okay, where marks, whatever you want, percentage, or maybe even, for example, time. I told you, whatever is there, the attributes, based on those attributes we can create a condition through a where clause. We'll go to the next question. Conversion of the domain name of each web server to its corresponding IP address is what? For example, there is a website called www.google.co.in. So this website everyone knows. So if we ask the IP address, nobody knows. Nobody knows. How can I tell? I don't know. That is better, right? So I don't know the IP address. It's very difficult for a normal user to remember the IP address. Okay, in terms of what? It'll be in terms of numbers. You need to remember the so many numbers. So instead of that, it is easy to remember in terms of words, and that should be very unique. That is called as domain name. This is called the domain name. Google.co.in is going to be the domain name. So using this domain name, ultimately, what is this? This is going to be a website. Website is basically collection of web pages only. Collection of web pages means what? You have to store it in a particular system only. No, which system are we storing? Which system are we storing? That system will have an IP address. IP address is going to be the internet protocol address. This mapping of the domain name, mapping of the website name to the IP address where exactly the web pages are stored is known as domain name resolution. Clear? So we'll go to the next question. Printing of documents within a building can be done by using which type of network? So within a building, so within this campus, I just want to have a network now. So we're going to do it using LAN. What is LAN? Tell me now. Local area network. What is LAN? Local area network. We'll go to the next question. Mobile phones are examples of which type of data communication? Mobile phones, for example, I want to talk to you people. Okay, you want to talk to me? That means we'll make use of mobile phones. That means communication. I will be talking, and meanwhile you will ask some doubts, and you will be talking. I'll be clearing doubts. So that means communication can take place simultaneously. Is the point clear? Simultaneously, both can talk, both can listen. That is called what? Full duplex communication. That's called full duplex communication. 14th question, with respect to the bandwidth, how many hertz can make 1 kilohertz? 1 kilo, I think you can make out. No, it's going to be 10 to the power of 3. That's going to be 1000 hertz. 1000 hertz. Okay, we'll go to the next question now. The malware that targets the user data. Okay, the malware that targets user data is going to be the spyware. Spyware is the answer for this question. We'll go for the fill in the blanks now. So what are the fill in the blanks? We'll just go through with the options now. The process of creating an exception object. Some error has raised now, some exception is raised. What do you do when an exception is raised? The interpreter is going to first create an exception object, and handing it over to the runtime system. Handing it to the runtime system is called what? Throwing an exception is called as throwing an exception. 16th answer. 16th means what? Throwing an exception. Dash process is also called as pickling. Pickling means what? Converting the Python objects to the byte streams. Where do I store it? Binary files. Who is going to do this? This is done by dump function. Dump function, load function, where is it stored? It is basically given in the pickle module. This pickling is called what? Serialization. Okay, what is very simple? If you don't want all those things, let me tell. Very simple. What is the answer for this? Serialization process is called as pickling. So that you know, along with that, you can learn little more concept. That is what my idea. Here, pickling is called serialization, unpickling is called deserialization. If you get that question also, you should be able to answer if you watch this video. Okay, unpickling is deserialization, pickling is serialization. So the answer is going to be 17th one now. Dash means same data duplicated in different places. Okay, in this file there is one particular details of the student. In this table also we have it, in that table also we have it. So again and again data is repeated in many different places. We call it as redundancy. Okay, it is called redundancy. Replication means redundancy. Okay, this is going to be 18, this is going to be 17th, I told you. It is called serialization. Serialization. Redundancy. Redundancy. Dash operator defines the range of values inclusive of boundary values. For example, I just want to know who has got which employee, which are the employees who got salary more than 40,000 and 80,000, including 40,000, including 80,000. Between operator. Between means usually will live. Right, but in between in case of SQL is going to inclusive. It's going to be inclusive of those two values. Between operator, so between is the answer for this. Defines the range of values inclusive of boundary values. 20th question, the function that converts a string into uppercase. Function that converts string into uppercase is what? Uppercase is upper. So here we have UCase. Okay, UCase is also an answer for that. UCase. From the given option, you have to select only, no? It's going to be UCase. Okay, we'll go to the next main. That's going to be 2 markers. So, write implementation of stack in Python to check whether a stack is empty or not. I just want to check whether a stack is empty or not. How do we check it? Very simple. So, we need to define a function. See, implementation of stack in Python. Let me just change it, okay? I'll just change the color now. That's going to be red color. So what is this? This is, I didn't change only, yeah. So nice. I didn't change the color. Okay. So def is empty. What is empty? Is empty is going to be a user-defined function. Any user-defined function, how you going to write it? By using a def function. Very simple. Def of is empty stack. If len of stack equal to 0. That means length of stack is 0. Nothing is there. That means it's like this. Do you remember in the previous video in model paper 1, they have just given like this. If stack equal to this, what is this? It's an empty list, empty stack. If it is so, it's going to return that, return true. If it is true, it is going to return that, return. It was just given return, that's all. Return, if was also not there, return only it was there. Okay, if case it is same means it's going to return true or else false, or else if you understand this better, you can write this only. Len of stack equal to 0, then it is going to be return true. It is empty. Else false. It is not empty. It is not empty. Something is there. It is going to be an empty stack. If something is there means it's not an empty stack. Very simple. Okay, we'll go to this 22nd question. For the elements, ZX and C perform NQ DQ operation. Only this is the question. Don't get confused. The question is only so much. They have not given anything else. What you can do, you can just perform 3 elements are there. We will do NQ 3 times and DQ 3 times. NQ 3 times, DQ 3 times. NQ I'm going to do it. NQ I'm going to do it. If I do NQ here, what happens? Z will come. Z will come. And after that I'm going to NQ. NQ is what? Inserting an element to the queue. NQ is what? Inserting an element Q. For example, there is Radha here, had taken one example. Radha, Krishna, and then what? Keshav. Radha is asking me the doubt now. And again Krishna will come. Will Radha allow Krishna to ask the doubt first? No. Radha only will ask the question first. Then Krishna will be joining where? Radha. After Radha, Krishna can join here. Then if Keshav comes, Keshav will join after. Keshav will comes means Keshav will join after Krishna, not before that. That means insertion takes place from the rear end. It's a simple queue. Remember that. Okay, NQ is inserting an element. Okay, after inserting Z, NQ is inserting only. NQX means what? Inserting from the rear end. That means now Krishna will come. Krishna will come after Z only. Right? Then we have NQC. NQC again it will be coming here only. This is going to be a queue now. After that we will perform 3 NQ operation, 3 DQ operation. Okay, first DQ operation was what? I'm going to remove what? After clearing the doubts, who will go first? You tell me. After clearing the doubt, who is going to go first? Radha will go out. Doubt is clear, she'll go off. She'll study some other subject. Okay, and after that Krishna I'm going to clear. Krishna's doubt I'm going to clear. After Krishna, then Keshav. That means deletion takes place from the front end. That means Z will be removed. After this, Z will be removed. That means only XC will be there. I'm going to remove this. After this, if I perform DQ, X is going to be removed. C only will remain. You can just see here, only C will be remaining. After that, one more DQ if you do it, C also will go off, nothing will be there. This is going to be an empty queue. Empty queue. Len of Q is equals to 0. It's an empty queue. Returns true. Clear? We'll go to the next slide. Okay, define the terms. We have 2 terms here. One is going to be hashing and perfect hashing. Okay, we have one concept here that's called hashing. 8, 7, 3, 2 we have it. Let's consider. Okay, 80 and 77 and 33 and 22 I'm going to take it. Okay, so we have an elements, and these elements has to be stored somewhere, and you need to search an element. I want to search an element whether 33 is present or not. In order to search 33 is there or not, what will I do? I'm going to first look at here, and then I say 33 is there. In case of hashing, we can just find out where 33 is present in just one step. What is hashing? A technique to find the presence of an element in a list in just one step. How do we do it? Very simple. For each and every element, we are going to store it in the corresponding index value defined by or given by the hash function. Store this 80 in the index 0. There will be something called as an hash table. In this hash table, what is this table called? This is called hash table. This is called hash table. Store 80. Okay, 4, 5, 6, 7. So I'm going to store this 80 here. That means take a number, divide by 10. What is the reminder? Take a number 80, divide by 10. 10 8s are 80. Remainder is 0. It is not supporting me. Why are you not supporting me? Okay, 80 I've stored here. Then 77 divided by 0. 77 divided by 10 and take a remainder 7. I'm going to store 77 here in index 7. Similarly, I have 33. I'm going to store it here. 22. I'm going to store it here. Understand that, students, I'm telling you, explaining the concept also here, so that you will not have any confusion in writing even 2 lines. You should not have any confusion even writing 2 lines. That is the main intention here, to explain so much even for the 2 markers. Okay, explanation is only so much is enough, but you need to understand, know what exactly is hashing. That is the reason I'm telling you. Okay, technique to find the presence of a key in a list just in one step using a formula called an hash function. For example, I'm going to give 55 here. So 55, where do you store it? 55 divided by 10 and check the remainder. What is the remainder? Whenever you take a number, divide by 10, you will always get the last digit of a number. That means I'll get 5. Let's store it here. Now tell me, where do I store this 64? Ma'am, very simple. What is there, ma'am? I will store it in 4 index. That's the point. If I give something like 71, very easily you will tell that stored in the index 1, because in one step you're telling, because you're not storing the elements randomly and then looking for it. No. You store the element consciously by finding the index using a hash function. That's called hashing. Just in one step you will get it. That's the basic idea behind the hashing technique. One of the best method. Okay, now the thing is that let's consider this example only. I have this beautiful example 80, 77, 33, 25 and 64. So is that each and every value has got, okay, I'll put here, each and every element in this list has got a different hash address. Hash address means what? Index, different index only it has got. No, it has got 0, this is going to be 7, and this is going to be it. Index I'm writing, okay, this is 7, this is going to be 0, this is 2, this is 5, this is 6, this is going to be 4, sorry, this is going to be 4. Each and every element is getting some different unique address, hash index it is getting. That's why we call such function as perfect hash function. If each and every element maps to a unique index in the hash table, we call it as a perfect hash function. That means without collision. That means if I take a number as 10, what is it? 10 means I have to store it in 0. 10 means I have to store it in 0. 80 also have to store it. 10 also have to store it. 80 have already stored. Where is the place for 10? No place. For one place, both the people are, like fighting each other. 80 is also fighting, 10 is also fighting. This is my place, this is my place. That's why we call it as collision. Collision. You have to avoid this, no? That's why collision resolution. That technique is called as collision resolution. Clear? We'll go to the next topic now. What's the next topic? That's going to be list any 2 uses of database in real life application. A huge collection of data wherein, you can easily store the data, organize it very well and retrieve it, manipulate it very efficiently. That is what you mean by database. Wherever there is an involvement of such huge database or data concepts, okay, we can have any of the applications to be written here. List any 2 uses: banking, agriculture, inventory management, organization, resource management. Okay, then we have an online shopping. Any example of your choice can be written. Clear? We'll go to the next example now. Next question, that's going to be 25th. Why delete statement is used for and write its syntax. For example, we have a table here. What's the table? Okay, we have a table here called the name, and we have a table called roll number, and we have a class. Okay, we have a class. So first name is what? Radha. Radha is there. Radha is there means Krishna to should come. Okay, Radha, Krishna, and then we'll take Sham. Radha, Krishna, Sham, and the roll number is 100, 101, 102. Class is what? Second PUC. See, I'm making them study in second PUC only. Second PUC, but Sham, we will put him in first PUC. I'm going to put the Sham in first PUC. Let them study in first PUC. Okay, so this is going to be my table, but I don't want. Okay, so these are the tuples, and this is going to be what? Okay, these are going to be the tuples. We call it as a tuple here, and these are called what? We call it as an attributes. Attributes. I'll come back to the slide. Let me remember. Okay, 25th slide. Okay, this is going to be my table now. So in this table called student, I just want to delete. I want to delete a tuple called Sham. I'm just explaining this concept only for the second PUC students. I don't want the first PUC students to be here. I don't want Sham to be here in this table. By mistake, I have put him in. So I want to delete this tuple now. How to delete it? By making use of a clause called, by making use of a command, not a clause, by making use of a command called delete command. How to call it? How to use it? So we need to write delete from table name where condition. How will I write it? Very simple. Delete from table name. Remember, in case of a DML command, table keyword will not come. Delete table name. No. Delete from table name only. Directly write the table name. Delete from table name where class is equals to first PUC. Class is equals to first PUC. Condition also can be given. Very simple. What is the syntax? Delete from table name where condition. Ma'am, I don't want any condition and all. You're a bit partial. I don't want any kind of condition. You please don't put any condition. I'm not going to put any condition. See here, students, I'm not going to put. Hold, all the records will be deleted. Be conscious. Be very, very careful when you're doing this. Delete from table means all the tuples will go off. All the tuples will be deleted. Table will be there, empty table will be there, all the tuples will be deleted. Be careful with the delete command, be careful with the update command. Okay, so we'll go with the next slide. So what is next? Write a note on the bus topology. What is topology? As I told you, what is topology? It's a connection of how the nodes are connected in the network. What is topology? A topology is collection of nodes in the network is called as topology. That means how the nodes are arranged. There is one node here, there is one node here, and there is another node here, and there is another node here. How the nodes are arranged. How are they arranged? Arrangement of nodes in the network is called as topology. One of the economical or the cheapest topology, if I have to tell you, that's going to be the bus topology. It's also called as linear topology. There is a bus. There is a linear bus. Okay, central bus. The central bus is also called as in backbone, where through the central bus all the nodes are connected. So this is connected to here, this is connected to here, this is connected to here, and this is connected to here. All the nodes are connected. And remember that each and every node has to communicate through the bus only. If this node wants to send, A wants to send, okay, let's name it A, B, C, D. Okay, A wants to send a data. A wants to send a data means it will be sending it through this cable only. But this message will be transmitted to all the nodes in the network. All the nodes in the network. That means C also will receive, D also will receive, B also will receive. All the nodes in the network will be received. But A wants to communicate only with C. Only C will respond to it because the address is C here. C here. And it's going to be one of the, okay, it's going to be less expensive. In that way we can tell it's very advantageous. But what if the central backbone only gone? If the cable only is faulty, entire network fails. That is a disadvantage here. Is the point clear? Maintenance is actually simple. It's less complicated. It's easy to maintain. Clear? We'll go with the next slide. So what is there here? We'll go for the next. That's going to be mentioned the different types of circuit switching. What are the different types of circuit switching? We have a packet switching and we have a circuit switching. What is packet switching and circuit switching? Very same example, I can take it. So there is a node here, there is a node here, and there is a node here, and there is a node here, and there is a node here. You need not have to explain here, but simply I'm just telling you so that you can have some understanding of the concept. There is an A here, there is a B here, and there is C here, and there is D here. Okay, some connections will take it. Okay, A wants to communicate with C. A wants to communicate with C. But here remember, in case of circuit switching, the circuit is already established. If the communication is taking place through the circuit switching technique, okay, circuit switching is used means the circuit has to be established well in advance and then the communication takes place. That means if the route is fixed that A will communicate to C via B only. That means this route only. Through this route only it has to communicate, not any other route. That means guaranteed transmission rate will be there in case of this. Yes, time delay will be there initially, but after that the data transfer takes place smoothly. That is going to be circuit switching. What is packet switching? In case of packet switching, if A wants to communicate with C, any route it can take. It can go via directly to this route. Let's consider as main node, something M, I'll take it. So it can go to M and then C, A, B, C, A, D. Okay, I'll connect this also. A, D. Okay, A, D, M, C. Whichever route it can take it, but the entire message has to be broken down into packets. Has to be broken down into packets. Hi, hello, namaste. Hi, hello, namaste. How are you all? How is the energy? Ma'am, what happened to you? Why are you telling this again? Yes. I'm on track only. I'm just explaining to this concept only. Hi, hello, namaste. How are you all? How is the energy? Such a huge message. Right? This message has to be broken down into packets and then only has to be sent. Okay, every packet will have a tight boundary. That's why it is called as packet switching, but it can go through any route. That is the thing. Okay, we'll go to the next question. What is the purpose of an assert statement? And write its syntax and give an example. What is an assert statement? Assert statement is basically used to raise the exception manually. Built-in exception, you know. Ma'am, what is this built-in exception? Exception is a runtime error. That disrupts the normal flow of execution. It is going to disrupt. That is an exception. You need to handle it. Okay, it will be handled by the interpreter. That is going to be built-in exception. Many of the errors will be handled by the interpreter. Those are called the built-in exceptions. There are some errors. For example, you are entering the age. I'm telling you to tell me your age. You're telling me in terms of negative. Ma'am, you told me to age. I will tell whatever I wanted. Can the age, you tell me, students, can the age be negative? No, right? I'm asking you your age. You have to tell me the age properly. If you type something else, then I have to tell you properly that this is going to be wrong. Please enter, give some positive number. Isn't it? So similarly here, in order to have some exceptions manually raised by the programmer. Okay, what is an assert statement? Assert is going to be a kind of an exception which is raised manually. In this case, in order to use the assert statement, you should always have a condition. If the condition fails, only this error will be raised. What is that error? Assertion error. Assert a statement whether it is true or false. If it is false, I'm going to raise the error. That is what the syntax. So look at the syntax here. Assert expression, and there is something called, ma'am, what is this square brackets? Ma'am, whatever is there in the square brackets, understand it is going to be optional. If you want, you can give it, or else it just says assertion error. Clearly give a message, no? Clearly, students, no, you're not supposed to enter, then give the age in terms of negative. Clearly say the message. They will listen. They will definitely listen. Yes, sir? Tell me. You will listen, right? Good, thank you. So we have an assert expression and then we have this. So let's take an example here. Enter the numerator, enter the denominator. And after that, we have one expression here along with the assert keyword. Assert number not equal to 0. Let's take the numerator as 50 and have entered the denominator as 10. Now, assert number not equal to 0. Sorry, number 2 is not equal to 0. Is it not equal to 0? Definitely 10 is not equal to 0. It is true only. That means the condition is true. Condition is true means no exception raised. It will go to the next statement. It will go to the next statement and it is going to perform. It is going to give 5. 5 it will give. What, tell me what it will give. It will give 5.0. It is going to be a float. It's going to be a float. And then it is going to print that float value. Clear? Okay, next what do we have? What if I give this value as 0 here? If I give n2 as going to be 0 here, assert n2. n2 means num2 only. It is the same thing. Okay, I'm making it shortcut here. n2 is not, n2 if I give 0. But they are telling it is not equal to 0. I made it 0. That means it's going to be false. When this is false, only assertion error will be raised. What is that assertion error? Clearly you are giving a message, denominator cannot be 0. When this is false, only then this will be raised. Clear the point? Any doubt on this? So purpose, syntax, example, everything I've told you, it's going to be 3 marker. 1, 2, 3. We'll go with the next question now. What's there in the next question? Write a note on the text file. What is a text file? A file, you know. What is a file? A file is a named area in the secondary memory. What is this? This is going to be a secondary memory. So in this, a named area in the secondary memory, let's consider a sample.txt. This is going to be a file, named file. And we're telling about the text file. How the text file will be there? For example, I have written, hi, hello, how are you? So here, the text will be a sequence of characters, including alphabets, numbers, special symbols, whatever you want, you can have it, even numbers also. Okay, spaces also, /t also, /n also, we can have it. Each and every character will be stored in its ASCII code. Each and every. For example, I have written A. I've written A. A I have written means internally it will be stored in its ASCII code value, even the Unicode also. ASCII code or Unicode. Unicode actually it forms basics of an ASCII code only in the beginning, right? So 65 it is going to store. Each and every character will be stored in the form of Unicode and ASCII code. Every line of text, for example, I have written the first line as hi, and second line is going to be hi, hello, namaste. Ma'am, what is this, ma'am? Every time you are using the same thing. Yes, this is going to be my tagline. No, I want to use this. I like this. Hi, hello, namaste is there. So this is going to be each and every line of text is terminated by a /n. In case of text file, each and every line is terminated by a /n. /n here means what? It's going to be an escape sequence. Here we call it as EOL character. What is that EOL character? End of line. That means the line has ended. End of line. It's the limiter, delimiter we call it. There is a concept of delimiter in the text file, but not in case of binary file. If you remember this, automatically you can tell that binary file also if they ask you the reference. Is the point clear? In the previous model paper 1 I have told you, I think one of you have asked me like how much will I get if I prepare model papers. Model paper thoroughly, if you prepare all the model papers what I'll be preparing, and I'll be giving the sessions. So 3 model paper, definitely I think you'll be able to score 40 to 50 marks. 40 for sure, 40 to 50, you know, I don't want to take a chance. 40 to 50 definitely you'll be able, but thoroughly you need to prepare. For example, if they ask one question on the sorting technique, the arrangement of elements, any numbers if they give also you should be able to do it. That is why going in depth for each question, so that understanding of the concepts can take place. Little bit here and there if the twist also, you should be able to write the answers. Getting my point? So we'll go over the next question now. End of line. Okay, /n is called as an end of line, and then the delimiter. Okay, so that's what I told you, special, separated by space, commas, everything you can have it. What are the examples for this text file? It can have some extension like .txt. No such txt. Do you remember in the previous video? No such txt. Sample.txt, .py. Do you remember somewhere? Do you have come across with the files called .py files? Anywhere else? .py? Ma'am, we have done with the labs, ma'am. What you forgot so easily? Yeah? .py is going to be the Python files. Okay, all your files will be by default will be stored as .py only, no? Python files. And .csv file. What is this CSV? Comma separated value files. All these things will be considered as a text file only. And how can you open any text file? With the help of any notepad, with the help of any text editor, you will be able to open it. But binary file, you need a separate application for that. Clear? We'll go to the next slide. Write a bubble sort algorithm to sort a list in an ascending order. So what is this bubble sort? Okay, so what is this bubble sort? Okay, so let's start with the next question. That's going to be 30th question. That's going to be write a bubble sort algorithm to sort a list in the ascending order. So little bit idea also I want to give on this particular topic, so what is bubble sort and how does it work. So we'll just look at that example and then come back to this algorithm part. Okay, so what I'm going to teach you, so I'm going to teach you on bubble sort. So bubble sort, we'll take an example also. So what's the number I have it? So 4, 3, 10, 4, 3, 10, 1, minus 6 and 2. I'm going to take this number. And remember that, students, I think I have told you many times that I know any kind of sorting techniques, what do you need it? You need a 2 loops here. You need a 2 loops. Okay, what are the different loops I needed? I need I need J, and I need some kind of comparison here, and I need to swap it. Very simple. Compare it, swap it. Hope you're able to see this part, right? So 2 loops. Which are the 2 loops? One is going to be I loop, another is going to be the J loop. What is an I loop? I loop is the same for all the sorting techniques. That's going to be 0 to n. 0 to n. What is the J loop? J loop will be starting from 0 to n minus I minus 1. Compare it. Compare L of J with L of J plus 1. Compare it. If so, you swap it. Hope you know how to swap it. Just remember, students, I just want you to remember A comma B is equals to B comma A. This is a swapping technique. If you remember automatically, these 2 numbers I'm comparing it, swap it. L of J comma L of J plus 1 is equals to L of J plus 1 comma L of J. Remember this technique called swapping here. You will be able to swap with these 2 numbers, these 2 variables. Clear? So I'll just give an example how exactly the bubble sort works. What is the bubble sort? Arrangement of elements only. Any sorting technique is going to be arrangement of elements only. Now this bubble sort, how does it work? Remember one part, writing part here, you need 2 loops, comparison, swapping technique. This should be the main basic thing you need to remember for writing the algorithm. Now we'll do it practically. I'm not going to show the whole thing, at least the first pass I'll show it so that the concept becomes very thorough to you. Okay, we have 4, 3, 10, 1 and 1 minus 6 and 2. So what happens here, it compares. When you have to explain bubble sort also, you can tell the same thing. Comparison compares the consecutive elements, compares the adjacent elements. Okay, after this is L of J and this is going to be L of J plus 1. L of J and L of J plus 1. Compare these 2. Yes, this is going to be, this is J and this is going to be what? This is J and this is going to be J plus 1. Okay, J is going to be more than J plus 1, so I need to swap it. 4 is more than 3. So swap it. 3, 4, 10, 1 minus 6, 2. After that, you keep comparing. No, move to the next adjacent elements. 5, 10, 4, 10. 4, 10 is already sorted. What is there? No swapping. Swapping is required here, but no swapping is required. Okay, we'll go for the next iteration. That's going to be 10 and 1. 10 and 1. Definitely 10 is greater than 1. I have to swap it now. So what I'm doing, I'm just comparing with L of J and L of J plus 1, and if it's greater, I'm swapping. So swap it. 3, 4, 1, 10, minus 6, 10. Again you move forward. Again you move forward, means forward direction I'm comparing. Remember that every time when you do it, increment the value of J here. Forward comparison, no, increment the value of J. J is equals to J plus 1. Clear? And after that, I'll compare 10 and minus 6. 10 and minus 6 is going to be lesser. So 3, 4, 1 minus 6, 10. Swapping. Swapping. Comparison. Okay? And after that, I'm going to compare these 2. 3, 4, 1 minus 6, 2, 10. This is also, I'm going to do the swapping. This is going to be for I equals to 0, and this is for what? J is equals to 0, 1, 2, 3, 4, 5, because J should be less than n minus I minus 1. So what is this in this case? J should be less than 6. That means 6 minus I is going to be 0 minus 1. 6 minus 1 is going to be what? J is equals to less than 5. 6 minus 1, 5. Is the point clear? That means you can just see here. In this case, 0, 1, 2, 0, 1, 2, 3, 4, and 5. Okay, and 5. So after this, in this case, what happens? Okay, I'm just checking here. Okay, so after that, what happens here? You can just see here the element is already sorted. 10 is already sorted. 10 is already sorted. This part is already sorted. This part is already sorted. Next, what happens in the next iteration? I need not have to do till, see, this is already sorted. I need not have to do this. No, see, 1 here, 1, 2, 3, 4. Okay, 4, 5, 6. No, 4, 5, 6. Yeah. Okay, so that's what I was telling you. So what I was telling you, see here, you can just see here 10 and, okay, 10 and 2 is compared. Now it becomes what? I just swapped it, 10 and 2 and 10. Now it becomes what? This iteration will be 5 now. Okay, when it becomes 5, what happens? Remember that you will not be able to compare as the value of n. J should be less than n minus I minus 1. 6 minus 0 minus 1. That means J should be less than 5. Does not satisfy the condition, comes out of the loop. Is the point clear? So remember, if you need, so 6 elements are 5 comparisons, you need it here. 6 comparisons, 6 elements are there, means 5 comparisons, you have to do it. N number means n minus 1 passes, you need it. Is the point clear? Very simple here. So in case of next iterations, in case of next passes, this is going to be the pass 1. Okay, this is going to be the pass 1. In next pass, second pass, what happens? Very simple. I'm going to start comparing from 3, 4. This is going to be what? This is going to be J. This is going to be the value of J. In this case, what happens? I compare 3, 4, 3, 4. I need not have to swap it. Let me just show you this. Okay, 3, 4, 1, minus 6, 2, and 10. So 3, 4, I need not have to swap it, but still the loop continues. 4 and 1 definitely needs the swapping. 3, 1, 4, minus 6, 2, 10, and then we have 4 and minus 6. Yes, swapping is required here. 3, 1, minus 6, 4 it becomes. And then what happens? 4, 2. 4, 2 means definitely it's going to be neat. So it's going to be 3, 1, minus 6, 2, 4, and 10. And again, it's going to be compared with 4, 10. Is that I need to do with 410? I need not have to do with 410 because it is already arranged. 10 is already sorted. That is what I wanted to tell you. J should be less than n minus I minus 1. What is the value of? Here you can just see here the value of J is equals to start from 0 only. I is equals to 1. In this case, I was 0. In this case, I is equals to 1. That means 6 minus 1 minus 1. 6 minus 2. 6 minus 2 means what, students? It is only 4. It is only 4. That means 0, 1, 2, 3. It's only 0, 1, 2, 3. 4 does not satisfy the condition, comes out of the loop. Very simple. That's what I'm trying to tell you. You need not have to do it. So this is 10 is already sorted. Here 10 is already sorted. Here 410 is already sorted. I need not have to repeat for till n. The elements are sorted from that end. From the reverse order, it is getting sorted. No, that's why the value of J will be what? J will be n minus I minus 1. Okay, we'll just go back to this part. That's what I have written here. This one point I want to tell you how to write the algorithm. Very simple. Whenever you are writing an algorithm, just remember that you are making use of while loop, not the for loop. So in that programming part, explanation part, representation part and all, we will make use of for loop only. But when you're writing an algorithm, all your textbook, all the syllabus, they are following the while loop only. Let me write the syntax for while loop. What is while loop? While condition will have an initial value here, condition here, some statements, increment or decrement will be here. So how do we write the while loop here? Okay, that's going to be I equal to 0 while I is less than n, and you can have some statements here, and then I'm going to write I is equals to I plus 1. This is how I write it. So similarly here, set I is equals to 0, y is less than n, repeat the steps. Repeat the steps from 3 to 8. Again, J is there, 0 to n minus I minus 1. 0 to while J is less than I minus 1. Keep comparing the element J to L of J plus 1. Keep it very simple, students. They have taken num list and all. Just take L. L means list, you will understand. List of L of J is greater than L of J plus 1 means I'll swap it. How would I swap it? I told you A comma B is equals to B comma A. I'm comparing with L of J with L of J plus 1. L of J with L of J plus 1. I have to swap with this. How will I swap it? L of J comma L of J plus 1 is equals to L of J plus 1 comma L of J. This is how I swap it. All square brackets, okay, all square brackets. By mistake it came out. It's not a parenthesis, it's a square brackets. So we swap it. You can show it. You can show it like this. Or just call one function called swap only. They have shown like that. You can show like this also. Remember to increment the value of j and increment the value of I. That's important. We went no equal to 0, equal to 1, equal to 2, equal to 3 like that. J equal to 1, 0, 2, 1, 3, 0, 1, 2, 3, 4. Similarly, you have to increment the value of j and I, don't forget it. Okay, we'll go to the next question now. What's there in the next question? That's going to be what? List the 3 possibilities that can occur in the binary search. In binary search, what do? I'm going to take that same element that's going to be 4, 3, 10, 1 minus 6, 2 is there. No. So this, I have to search the element. How do I search the element? I have to search the element using binary search. Means it has to be in a sorted way. Sorted way means what? First you sort the elements. That means, ma'am, how will I sort it? Make use of bubble sort, insertion sort, selection sort, any of your sort which you like it. So minus 6, 1, 2, 3, 4, 10. See, just by looking at the numbers, we will be able to sort it. But writing the instructions, it takes so much of time, isn't it? So here, 6 is there. Okay, we need to sort the elements. After sorting the elements, how will I do with the binary search? I'm going to fix the boundary here. I'm going to fix the boundary here. What is the boundary? Any element, if I have to find out, I have to find out element. Let's consider I want to find out 4. If I want to, for example, my key element is going to be 4. If I want to search key element, that means what will I do? First fix the boundary. Element should be between 0 and n minus 1. It should be between this index 0 and n minus 1. That is for sure. So for that, I'll keep one variable called beginning. Beginning is equals to 0. End is equals to n minus 1. Fixing the boundary. Element should be between this. After that, what do? Find out the middle value. What is the middle value? Middle value is equals to beginning plus end by 2. Beginning plus end by 2. What is beginning plus end by 2? 0 plus, what is the index? 0, 1, 2, 3, 4, 5. Index is 5. 0 plus 5 by 2 is what, student? 2 only. Ma'am, why are you telling 2? 5 by 2 is 2.5. Definitely 2.5. We will ensure that we will take an integer part of it. We'll take an integer part of it. That's going to be 2 only, integer part. Out of 2.5, I'm only truncating that decimal point, taking only the integer part. That's going to be 2. So find out. Is 2 equal to 4? Definitely not. So if the middle element matches the key, search is successful. If the key element is 2, successful. Yes, element is present in 2. Done. Job done. Going tata bye bye. What if the element is greater? In this case, it is true. What if the key element is greater than L of mid? This is going to be my mid. What if L of key is going to be greater? In this case, 4 is greater than 2. Yes, ma'am. So what? Then refix the boundary. Where to where I should search? Search in the left side. If the element is greater than the key, search continue. Sorry. It's the middle element. If the middle element, if this is going to be greater, in our case it's going to be less. No, if the middle element is smaller than the key, search in the second half of the list. Or I'm just telling the other way around. Other way around means what? If the key element is greater, if my key element is greater, means what I do? I'm going to search in the second half. Second half means what, ma'am? From here to here. Here to here, not this also. This, from this I should consider, from 3 you consider, ma'am. How to consider? Make the beginning as, in this case, make beginning as mid plus 1. Make the beginning as mid plus 1 from here, because end is fixed here only. Make the beginning as mid plus 1. What if the element is here? Minus 6 I have to search. Change the end. Change the end. What if the key is going to be lesser? If the key is less than the L of mid, change the end is equals to mid minus 1, because this is already searched. I have to search from this part. Mid minus 1. End is equals to mid minus 1. Very simple. What if the key element is going to be same as mid? What if the key element is going to be greater than L of mid? What if the key element is less than L of mid? These are the three cases you have to remember. We'll go to the next question. Explain the limitations of the manual record keeping. So 3 marks you have to answer for this question. So for example, first PUC students are there. They have cleared their exams and they've promoted to the second PUC. They're promoted to the second PUC. So for second PUC, what you have to do it, same if you're doing manual entry, means again you take one register, keep copying all the student names. Radha, Krishna, then Keshav, then Shama, whatever is there. Now you keep writing the names of the students again. Ma'am, it is time consuming, ma'am. Why are you writing again and again? Time consuming, yes, that is the limitation. Ma'am, accuracy, what about the question of accuracy? Don't you think it leads to some kind of, what if you make some mistake? That leads to inconsistency, prone to errors, inconsistency. For example, you made one mistake. Instead of Krishna, I've written as Keshav. Instead of Krishna, I've written Keshav. And you're searching for Krishna there, you're not able to find only. So, even that updation, modification, everything becomes wrong there. Inconsistency. It results in wrong results, you're going to get it. Is the point clear? And what is that? Difficult to update. Storage issue is there. What if the register only got damaged? Isn't it? So there are so many probabilities will be there. So these are the limitations of manual record system. This is very important that you remember that this is what this normal register only we are talking. Normal file storing only you're talking. Okay, so we'll go. File means not that file handling, not that file. Normal register. We will talk in terms of register. File also word we will not take. Differentiate between a single and multiple row function. What is single row function and multiple row function? Single row function means what? That means example is going to be what? Square root, power function, or it can be with respect to UK's length. We have no. So we have these functions, we call these functions as single row functions. That means what? Operates one row at a time. One row at a time only it can find out. For example, there is a string called, what is string? Let's consider that we have a CS session. There is a CS session here, and this I need to find out what is the length of the string. There is a string called CS session. So this length of the string I need to find out. How to find the length of the string? We have a function called length only, ma'am. For the single cell value only I'll perform note. Students, we'll go back to that. Can you recall or tell me the what question number where I wanted to explain again? See if you can go back. I'll just show you here. So it is not stored, huh? At it, no. Okay, we'll go back. Let's see. I think I've stored it in. See here. Yes, good. I'm able to retrieve it a bit early only. Good. Okay, so now, okay, so we have this Radha Krishna Sham, no? So what is that I wanted to do? I just wanted to. So what was the question? Let me just check and then recall, no? I just forgot the question, students. Single row function I was explaining, no? Yeah, I just want to. See, there is a string called Radha here. Okay, there is a string called Radha, and I just wanted to change the name. I don't want Radha, I want to store as Radhika now. I want to do some changes with respect to a single value. Not the entire row, student, just not the entire row or not the entire column, just one cell. For that they are telling a single row function, one cell value, actually speaking is one cell value. Length, or you want to find out, you wanted to round off some, for example, we have one percentage, I just want to round off. I want to calculate some power function. So one single well, that's called as single row functions. Okay, so we'll go back to that slide now. So what is the slide? Can you able to tell me? Oh, that's nice. Okay, we'll go back to this now. So operates on a single row, one row at a time. Returns one result per row. It results one result only. For example, length of this side, length of this particular string means it will give that value only. One value only it will give. Can be used in select, where clause, and order by clause. So in all these clauses you can use select clause, where clause, order by clause. Order by is what? Sorting of elements only, okay? So what are the examples for single row function? Math functions, string functions, date functions, these are all the single row functions. Single row function, what is the other name, you tell me? Single row functions is also called as scalar functions. What? Can you repeat again? Single row functions is called as scalar functions. Ma'am, how can we repeat, ma'am? How can we repeat? The tendency is there. No, I keep asking like that. That's okay. You can repeat through. You can just repeat through. Commenting. Why don't you comment it so that I can see? I can understand that you're actually concentrating. Okay, we'll go for the multiple row functions. Multiple row functions are also called as aggregate function. What is that? Let me repeat it. Single row functions are called as scalar functions. Multiple row functions means what? Aggregate function. Aggregate function we call it. Operates in groups of rows. Operates in groups of rows. Groups of rows. For example, we'll go back to that slide only, the 25th slide only. We'll go back to this now. So in this slide, I want you to tell me, okay, in this slide, I want you to tell me how many tuples are there in this. Ma'am, what is this tuple and all, ma'am? We are not understanding. Tuple, you don't know. Tuple is that only, students. Total number of rows or records in the table is called as tuple. What is tuple? Tuple is a single row. How many tuples are there? 3 tuples are there. 3 records are there. 3 rows are there. No, those are called tuples. So how many tuples are there now? 3 tuples are there. How to find out if 1000 tuples are there? Will you count it? 3 tuples are there? I'm able to tell. If 1000 tuples are there, means I can't tell. You find out no using function. I will tell which function you will use. You will make use of count function. You will make use of count function. Count star function, you will use it. When you use count star function, it not works on single row. It works in multiple rows. Multiple rows. Those are called as multiple row functions. Those are called as multiple row functions. Those are called as multiple row functions. Okay? Groups of rows. How many values it gives? It gives one value for multiple rows. See, it returns one result for a group of rows. For multiple rows, for group of rows, it gives one value only. Can be, remember this, they had asked in one of the preparatory paper, remember this very important point, aggregate function, multiple row functions can be used only in the select clause. Very important MCQ if they ask you. Okay, it's somewhere in the corner, you have to remember this. Aggregate functions, multiple row functions can be used only in the select clause. What, ma'am? Not in the where clause, not in the order by clause. You can use it only in the select clause. That's what they're telling. So example for aggregate function, max function, min function, sum function, count function, average function, not average function. What is that function called? AVG function. Average only. No, don't remember as average, remember as AVG only, so that you will not make a mistake. What is that? Function called as AVG function. Average only it will find out, but remember as AVG. Okay, we'll go for the 34th question. Expand the following: MAC, HTTP and URL. URL or URI? URI, sorry. URL. URL is Uniform Resource Locator. URI is Uniform Resource Identifier. What? Uniform Resource Identifier. I just started from the third one only. Okay, this was not visible to me, so only I told. URI is what? Uniform Resource Identifier. HTTP is Hypertext Transfer Protocol. MAC is going to be Media Access Control Protocol. What? Media Access Control Protocol. We'll go to the next question. So we'll go for the 35th question. Convert the following infix notation. What is it, infix notation? Ma'am, you told somewhere that infix notation in the model paper 1. Have you come across? Have you gone through with that video? So what is infix notation? Infix notation is basically an expression wherein the operator comes in between the operand. This is infix. What is postfix? Post the operands. That means the operator comes after the operands. Convert this to this. Convert the infix to postfix expression. How we can do it? I am going to show you the working or conversion the way it is shown in the textbook only. I'll just show it to you in this way. They have given in some of the handbooks and all, they have given you in this format, but I feel it's going to be more easy if you show it in that way, because the concepts will be very clear to you. Okay, let me show this here. So what you're supposed to write, you're supposed to write the symbol. Let me change the color. Okay, let me write this symbol and then what? Action and then stack, and then postfix. What is postfix expression? Hope you know. PE. PE is postfix expression. Okay. I'll change the color now. I just want to change the color to yellow. Everything yellow, yellow. My dress is also yellow. Even this is also yellow now. So what is the first symbol? The first symbol is going to be A. Okay, let me explain to here and then come back to this. How do we convert infix to postfix expression? What is the algorithm, ma'am? First you tell me the algorithm, ma'am. We'll do this later. Very simple. Infix to postfix means what are the probability or what all the characters you may come across. You may come across parenthesis. You may come across right parenthesis. You may come across operator. What, ma'am? Operator. Operand. That's all. That's all. Parenthesis, left parenthesis, right parenthesis, operator and operand. What if you get left parenthesis? No worries, push. No worries, push. If you get right parenthesis, pop it. When you pop it, what do? Append it to the postfix expression, append it to the postfix expression and discard. Discard what? Discard the operator, discard the both the parentheses. 1 minute, let me erase this part. Discard the see, I'm using eraser, I'm trying to erase. What is this I'm trying to do? Okay, discard the left parenthesis. What we have to do? If you get left parenthesis, you push it. If you get right parenthesis, you have to pop it. Pop it. Append to the postfix expression, discard the left parenthesis. If you get an operator, what to do, ma'am? If you get an operator, check for the precedence. What is the precedence? The precedence is first precedence is going to be the power symbol, then we have multiplication, then we have division, and then we have what? Percentage mod, and then plus and minus. This is going to be the first priority, second priority, and third priority. Remember this. Okay, priority wise, as you already know this. Okay, first comes the power symbol, and then we have multiplication, division, and then the modulus, and then plus minus will take the third priority. And out of this, the least priority is going to be the least priority will be what? The parenthesis. Left parenthesis will be the least priority. Okay, check for the priority. This means priority. If it is having greater precedence, greater priority, very simple, push. Push. Greater precedence means you push. If it is having less priority or equal to priority, same priority, plus minus, I got it, same priority, what you have to do it? You have to pop it. You have to pop it, keep popping till the operator of the infix expression, the operator that you got, and the stack operator is same. It should be same. It should be greater. If this operator is greater than the stack operator, only then you can push it. What I told, if the operator is greater, having greater precedence, you're going to push it. If it's having lesser precedence or equal to precedence, you keep on popping, keep on popping till the operator what you got becomes a higher priority. Once it becomes a higher priority, what do you do it? You can push it. No, you can push it. When you pop it, what you have to do? You have to append it. Okay, whenever you pop it, you have to append it. Operand means what? Very simple. You have to append to the postfix. Append to the postfix. This is going to be the major thing for you to understand. Okay, let me write it. So what is this? I got A. What I have to do with A? A is going to be an operand. Operand means you simply have to push. I'll append ಮಾಡಬೇಕು. You have to append. So I'm going to write A here. What is stack? Nothing is there in the stack. Then we have got this plus. So if I get this plus, what I have to do? When I get plus, plus is an operator, check the precedence with the stack operator. Nothing is there in the stack. It is having its Raja Rani. That's what I told you. That is the queen, that is the king. So you just push to the stack. That means I have to push it, check for the precedence, it is having higher precedence. I'm going to push to the stack. Then what do we have? Postfix expression remains the same, A only. Then we have this. Then we have, what is this? B. B means what is an operand? That means I have to append it. Append where? I have to append to the postfix expression, stack remains the same, plus only. After this, what do we have? This is going to be minus. Minus means what I have to do? Minus is an operator. Operator means what? Check for the precedence. Precedence minus plus. Check with the stack operator. Same precedence. Same precedence means what? Equal to precedence means keep on popping. Keep on popping. Pop it and then append it. Okay, I have to pop and then push. Okay, I will pop out this. When I pop out, it will come out. No, I'll pop out. I have popped out. Okay, I have popped out. I have popped out this. When I pop it, I have to push it. No, only no. After doing popping, I will push it. I will push it. I have popped out plus, I'll push minus now. After doing that, what do we have? We have this C. C means very simple, append. This remains same, minus AB plus C. Then we have star. I have star. Star is very simple. Check for the precedence. Check. Precedence is going to be, star is having more precedence than minus. So it is having higher precedence. Push. I have to do push. How can I push? It is not supporting me. See, how can I do push, students? It is not supporting. So let me write it now. Yes. So it is push. Let me push now. After pushing, what I'll do? It's minus and star. And this is going to be the same. AB plus minus. Okay, after this, I have something called D. D means what? Append. Append. Append where, ma'am? Append to the postfix. CD I got. It is CD only. Okay, CD I got. Is there any other character? No character, only you keep on popping all the elements. How will I pop it? I'm going to pop star and then minus. This is the final expression we have to get. Is it right? Ma'am, you've written something. Is it right or not? How will we check? We can easily check, students. I'm going to write now. Okay, this checking I will show you in the another color. Which color shall I show you? I'll show you with green color. Green, no. No, I'll show you with blue. A, B. Can you able to see this color? Yes. A plus B minus C star D is there, no? Okay, we'll just do this. See, look at the precedence. So, star should be having higher precedence. So, first that I'm going to do CD star. So, then I'll take it from left to right. When having same precedence, just go evaluate from left to right. AB plus postfix. I'm just doing postfix now. Infix to postfix, manually checking. Infix to postfix, manually I'm doing. How, ma'am? A plus B means AB plus, no, AB plus, right? Similarly, C star D means CD star. A plus B means AB plus minus. This is 1, this is 1. Do it, no? So that's going to be AB plus CD star minus. Did we get? Yes, we got. Yes, we got. We got, no? So we'll just go with the next slide now. Okay, so we'll go with the next question. What is there in the next question? The next question is define Deque. Explain the operations on Deque. Very simple. What is a Deque? Deque is a version of Q wherein insertion and deletion takes place from both the ends. That means inserting an element and deleting an element takes place from both the ends. So what is that both the ends? That means I can delete from the front end also. I can delete from the rear end also. Okay, delete front, delete rear, insert front, insert rear. So what is a Deque? Just an explanation for that, wherein elements can be added or removed from both the ends. So insertion takes place from the front end. That means the same example will take Radha is there, Krishna is there, and then we have, and Sham will come. So Sham can come from front end also. Sham can come from rear end also. I can delete Sham only first. I can delete Radha only first. The way I want, I can do it. Insertion, deletion can take place from both the ends. That is what you mean by Deque operation. So explain all those. 1 plus 4, totally it will be 5 marks. We'll go to the next question. That's going to be 37 question. Give the other name for the linear search and write an algorithm to find the position of an element using a linear search. So what is a linear search? Very simple. Linear search is going to be one of the searching techniques where the element is searched in a sequential way. One after the other. Okay, and one after the other we're going to search the element. So let's take an example now. So what is the example? I'm going to take the same example as 4, 3, 10, 1, minus 6 and 2. I just want to search the element. Remember, linear search can be applied for sorted and unsorted. For a smaller list, no, this search works very efficiently. For a bigger list, number of iterations will be more, right? So for example, if I want to search 2, then it will take n number of iterations. For example, if I want to find out the element in 1000th element, so the element is in the 1000th place. 1000th element means what? It will be 999, right? That means it will take 1000 iterations only it will take, right? So it works for a smaller list. Okay, we need to find out, write an algorithm. Give the other name. What is the other name? Sequential search or a serial search? The other name for linear search is going to be a sequential search or the linear search. And let's look at the algorithm now. So how do we do it? I'm going to start from the beginning till the end. I don't know where is 2. I just want to search from the beginning till the end. Beginning till the end means what? I'm going to start from I. I is going to be 0. I is less than n. And then I plus plus, I'll be doing it. What I'll be doing it in each thing? Comparing. Is it 2? Is it 2? Is it 2? Is it 2? Is it means what? Comparing only. No. How will I compare? L of I equal to key. Let's take key element is equal to be 1. Key is going to be 1. Okay. Key is going to be 1. Key is going to be 1. Okay. Okay. This is going to be initially 4. Sorry, initially. Hope you are able to understand what I've written. Okay. This is the index. Let me write the index in a different color. Okay, I'll write it in blue. The index of this. Okay, the index is going to be 0, 1, 2, 3, 4, 5, and 6. Okay, what is the index? So I just want 5. 0. 0 is less than how many elements? 6 elements. 0 is less than 6. Yes, it satisfies the condition. Yes, it's within the condition. So L of 0 equal to 0 equal to 1. Key element is 1. E is L of 0. What is L of 0? L of 0 is going to be 4. E is 4 equal to 1. No, it does not satisfy the condition. It does not satisfy the condition. Go to the else means I is equals to I plus 1. Increment the value of I. That means I become incremented here next time 1. 1 is less than 6. Yes, it satisfies the condition. What is L of 1? L of 1 is going to be 3. Is 3 equal to 1? Does not satisfy the condition. Does not satisfy this condition. Then means it will go. No, it is not found out. It will go for the else part. 2. 2 is less than 6. Yes, it satisfies the condition. L of 2 equal to 1. What is L of 2? 10. Is 10 equal to 1? No, does not satisfy the condition. Increment the value of I. That means 3. Is 3 less than 6? Yes, it satisfies the condition. What is L of 3? L of 3 is going to be what? 0, 1, 2, 3. 1 equal to 1. Ma'am, we found out. When we found out, what you have to tell? Element found at position I plus 1. Third is there, 3 is the index, plus 1 you make, fourth position. Found at I plus 1. Stop it. Just stop it, come out of the loop. Okay, so we just come out of the loop, and then what do we do? After doing it also, we'll come out of the loop only. We'll just come out of this entire function only. Okay, or else we'll just say that search unsuccessful. Clear? We'll go to the next question. So what is there in the next question? That's going to be the 38th question. Define the following terms. So define the following terms. What are the terms here? Attribute, tuple, domain, degree, and cardinality. Okay, so what do we have? Attribute, tuple, domain, and degree, and cardinality. What is attribute? Attribute is going to be a unique, distinct name for each and every column. Each and every column can have a distinct header that is called as an attribute. Attribute, field, or a column. It is the same. Okay, so we have in tuple. What is a tuple? Tuple is going to be a row, a record, and a single entry in a table is called as a tuple here. And then domain, a set of possible values of an attribute can take is called as a domain. And we have degree, number of attributes in a relation is called as degree. Total number of tuples is called as in cardinality. Okay, I'll just show you this with an example. That 25th slide, no, I like it, so I just want to go again and again. Okay, what is this? So we have this table here now called student table. I just want to find out which are the attributes. Attributes are name, roll number, and CS. I can't give name again. Unique name given to the column name is called as an attribute. It's called as an attribute. Okay, what is a tuple? Tuple is basically what? A tuple is basically each and every entry in a row is called, each and every entry in a table is called as a tuple. I told you many names are there for the tuple. Tuple is also same, row is also same, record is also same. All are the same only. This here we have one tuple, Radha tuple, then we have Krishna tuple, and then we have Sham tuple. I told you how to count the number of tuples. No, it is the same concept we are teaching here. That's going to be a row or a tuple or a record is one and the same. A single entry is known as a tuple. Clear? So, and then after that what we have a domain, a set of values. A set of values an attribute can take. A set of values an attribute can take is called as a domain. A set of values an attribute can take, permissible values that an attribute can take. For example, I have given a roll number is going to be an integer I have taken. You can't enter some other value here. A set of permissible values only you have to enter for this particular attribute. No, I can't enter something as a character here because the data type is going to be an int. So we call it as a domain. There, set of permissible values for a particular attribute is called as domain. And after that we have a degree. What is degree? Total number of attributes. Total number of how many attributes are there? 1, 2, 3. 3 attributes. Degree of this table is called 3 now. What is cardinality? Number of tuples. How many tuples? 3 tuples. That itself is the cardinality. We'll go to that. Can you tell me which question I was doing? Can you comment it? Which question I was doing? Okay, I was doing 38, so I have finished this. We'll go to the next question. That's going to be an explain different networking devices used to configure the network. So which are the networking devices? We have it. So we have a modem, we have an Ethernet, we have an RJ45, repeater, switch, hub, router, gateway. You can write any 5 networking devices here. So what are the networking devices? We have it. So we have a modem. Modem is going to convert analog to digital, digital to analog. Analog to digital, digital to analog. That's what you mean by a modem here. Converts digital to analog and vice versa. You can say vice versa. What is Ethernet card? Ethernet card is also called as a network interface card. Okay, network interface card. Athwa network adapter also we can call it. Okay, it basically connects the computer to the network. It's basically a PCB that is stored, inside. It'll be there in the CPU, wherein it's basically help us to connect to the network. So for this device, for this Ethernet, you need to have one wire or an Ethernet cable given by the ISP, Internet Service Provider, to connect to the network. We have to connect. That means a wired network from the broadband connection, what we get from the Internet Service Provider, that should be connected to this Ethernet card. Right? That means that can be done with the help of a 8-pin connector that's called an RJ45. 8-pin connector using an Ethernet cable. Okay, how will we have the connection for this 8-pin network, for this Ethernet card? Okay, so let's continue now. So what is this RJ45? RJ45 is going to be what? It's an RJ45 is going to be an 8-pin connector to this Ethernet card only, wherein using an Ethernet cable you will be able to connect to that card. Very simple. Why? For connecting devices to the network, as simple as that. And for example, there is a source and there is a destination. I need to go from Bangalore. Okay, from Bangalore. Why Bangalore? I want to take up Talgatpura. From Talgatpura, I want to go to Banshankari by walk. Just by going from here to Konankunte only, I'm tired. I got tired. Think of going from Konankunte, I have to go to Banshankari. Then it takes a lot of time. I'm tired in Konankunte cross only. So what should we do? then we need to get energized. No, we need to have some, you need to have some energy drink or something like that, drink some water or eat something, and then you can continue your journey. Similarly, for a message, for a data to be transferred from the source to the destination, on reaching itself, the signal gets attenuated. So you need to regenerate the signal so that the destination can reach the message, so that the actual message can reach the destination. It should not get attenuated. Yes, of course, it's get attenuated in the middle only. You need to regenerate the signal. That is taken care by the repeater. That's taken care by the repeater that regenerates the original signal so that it can, what is this happening? So that the signals can reach long distances. Okay, we'll go for a hub or a switch. What is hub or a switch? Hub or switch is basically a central device that is usually connected in the star topology. It connects a multiple devices. What is hub? Hub is going to be connect a multiple device. For example, here we have a central device. Here I have a node, here I have a node, and here I have a node, and here I have a node. All these device has to communicate via the central device only. No, you have to follow me. You have to send it. You have to receive whatever through me only. You have to do it. That is called star topology. No, so this central device can be what? This central device C can be an hub or a switch. What is this switch is doing or hub is doing? Hub is a central device that connects multiple devices in a network. Connects multiple devices in the network. Then what is the difference, ma'am? Hub is a device wherein it broadcasts. You know what is broadcasting? TV broadcasting, radio broadcasting? No. For example, there is Radha here and Radha wants to share something. See, Radha is there. Radha wants to share something to Krishna. Okay, secretly she wants to say something to Krishna. But Radha, when she has to communicate to Krishna via central node only, it has to communication should take place. When Radha is communicating something, this central node is going to do broadcasting. What is broadcasting, ma'am? That secret will be told to everyone. Broadcasting means broadcasting incoming data to all the connecting devices. To all the devices it will say. Okay, that is one hub. That means chance of collision is more. No filtering, nothing. No filtering, nothing. It's going to tell to everyone. That is hub. What is a switch? Switch is also a central device that connects multiple devices, but here it is going to do unicast, not broadcasting. That means Radha's secret will be told only to Krishna, not to anyone else. And here the collision is not going to happen. Reduces collision, I can tell. Okay, it reduces collision. Unicast. Okay, it knows to do the filtering. Okay, so that is what you mean by switch. Your router, it connects different network, analyzes the data. So for example, here is one network, there is another network. In order to have different networks to communicate, we need to have a router there. We need to have a router. To have a communication within the network means we have an hub or a switch, central device. So within the network, of course, also we can use a router here. In order specifically for connecting two different networks, we need to have a router there. Is the point here? So router basically is going to analyze and retransmits the packets if it's required. That's what you mean by with the help of an IP address. Okay, with the help of an IP address. Okay, what do we have? IP address is going to be the internet protocol address. It's a logical address. What is in detail of this we will be explaining in the chapter data, computer network and data communication and all is there. No, in detail we will explain there, or else it's going to be, the video is going to be very lengthy. If it's too lengthy, students will not watch. Will they watch? Will you watch? Good. So we will continue in detail in that session as well. Okay, so we have a gateway here. What is a gateway? Gateway is gate only, ma'am. So what exactly the gate is going to do it? The security standing in front of the gate, what is he going to do? He is going to monitor each and every person entering and leaving the campus. Right? What exactly a gate is going to do, or the person standing in front of the gate, the security is going to check. He's going to check each and every entry or exit. That means act as an entry or an exit point between the internal network and the external network. Whoever is entering into your campus or whoever is leaving from your campus, each and every person will be monitored. Every packet that's entering and leaving the network will be monitored. Who is doing that, ma'am? That is done by the router only. And this concept we call it as a gateway. There is no device as such as gateway. It's a concept only, but router can act as a gateway. A router can act as a gateway, means it's monitoring each and every packet that enters and leaves the network. That is called a gateway. Okay, we'll go to the next slide. So what is that? We have it. It's a very simple question. What are the three categories of wired media, and explain any two? So wired media, we have a transmission media. Remember, transmission media with respect to the cables you have to explain. Is it only cables, ma'am? Is it only wired always? Definitely not. Wired, wireless, guided media, unguided media, it is there. Just I told you, no, you should not get communication, you should not get confused with the communication modes as such. That's going to be simplex, half duplex, and then we have full duplex. No, that you should not get confused. So we have three categories of wired media, especially wired only they've asked here. So you need to write only related to the guided media, that is wired media. So what are the different wired media we have it? Twisted pair cable, coaxial cable, optical cable, very simple. So we have two copper wires twisted. Why it is twisted? Like a helix, DNA helix. Basically this twisting helps in reducing the electrical interference, and definitely it is used in telephone lines and LANs. And we have two types of twisted pair cable, that is UTP and STP, unshielded twisted pair cable and then shielded twisted pair cable. And we have a coaxial cable. So central copper wire basically surrounded by an insulator. Here two copper wires only are there. Basically it is insulated with each other. That is important point. So we have an outer conductor and we have an inner conductor also, basically surrounding the insulator. Here insulator is used. Okay, here we have an less interference is also less and higher bandwidth when compared to that of twisted pair cable. And usually, cable TV, broadband internet connection and all, we make use of this. Speed is also more here. Optical fiber cable, that means OFC here. So here the data will be transmitted in the form of light. Total internal reflection is the concept that we use here. And also remember, it's going to be very expensive, and maintenance is also a bit difficult. And of course, no interference only, they say. No interference, and the bandwidth is going to be very high and faster data transfer. So we have a lot of benefits also, but expensive, and then also we have this maintenance issue also is there. So any of these two you can tell. So how is the scheme of valuation? This is going to carry 1 mark. Just mentioning will carry 1 mark. Any two explanation, 2 marks for this, 2 marks for this, and 2 marks for this if you attempt this part. Any two you can write it. We'll go to the next question. List and explain the different types of security threats. So what are the different types of security threats we can have it here? That's going to be denial of service. See, DOS, denial of service, an attacker where a resource like a website or a service is overloaded with a fake request that legitimate users cannot access it. So what is DOS? DOS is denial of service. Let's consider one server here, and this server is actually, what is the job of a server? Server job is to receive the request, process it, and gives back the information, necessary information back to the client. That is what a server's job. But this server is overloaded with the fake request. Genuine request is different. Fake request will be different. That is what they're telling. Illegitimate users will send a fake request. That will make the legitimate users cannot access it. Genuine users, real users will not be able to use it. Hackers use this technique so that the server is actually not reaching the server is not able to work for the genuine users. That is called denial of service. And what is distributed denial of service? What if this overloading of fake requests comes from different places, from different networks around the globe? That will become a distributed denial of service. Same only, overloading of fake requests to the server only, but different places, different networks. And this infected machines will be having this software called as a bot, And this infected machines, we call it as in zombie machines. Malicious software is known as bot. Malicious software is called as bot. And this infected machines, we call it as zombie machines. Is the point clear? So if it comes from many infected computers, so that the real users cannot use the network. That is what you mean by distributed denial of service. What is intrusion? Any unauthorized access or activity on a network that threatens its security of data. That means, for example, whatever you send it, any kind of malware. So many malwares you have studied, right? So any kind of malware which you are not able to, through any kind of malware, you'll not be able to use your own resources. You're going to block your own, so it's going to block your own resources. That's what they're telling. Threaten its security. Security is one issue. Unauthorized, you have not given the permission, they're using it, they're blocking it. So that is one of the way of having a security threat. Different types of security threats, it's intrusion, Trojan worms, hacking attempts. These are all some of the examples. Okay, then we have snooping and eavesdropping. What is snooping? Secretly capturing and analyzing the network traffic to steal information without affecting communication. That means what? Very simple, I will tell you here. Snooping means, okay, let's consider that you have two friends and they're talking each other. Let's consider that Radha and Krishna, they're talking, and the Shyam is there, he want to listen. He want to listen to their conversation. Shyam and Krishna, Radha and Krishna, they're talking, and Shyam wants to listen, but he's very much sure that these people will be very conscious that, they will not make him to listen. If they come, they will not be talking in front of him. It's like that. Okay, what he will do, he is going to keep one mobile and then he will record the message. There is a chance that you may get confused with snooping and eavesdropping. That's why I'm giving you this example. What they will do is record it and then he will listen to the conversation. What is it? Secretly capturing and analyzing the network traffic to steal information without affect. He is not affecting the communication. He is not interrupting their communication. So the communication is taking smoothly only, but he is secretly stealing the information and analyzing the network traffic. Very good example is that I have sent an email to you people. I have sent an email to Puneet, and when I have sent an email, there is another person sitting there. He has read the packet what I have sent. This email also will be sent in the form of packet. No, this packet will be received by an hacker. He is going to analyze what I have sent in the email and then he will send back. Puneet also will receive that. Tap the communication, read the packets, and then reinject the packet back to the network so that the network appears to be normal. That is what you mean by snooping. It is not going to happen in life. Okay, communication, later, record it. That's what you mean by it. We'll go for eavesdropping. What is eavesdropping? Unauthorized real-time interception of communication between two parties over a network. Unlike snooping, it happens live. It happens live. For example, Radha and Krishna are talking. They wanted to converse. They want to have, they are having some conversation and Shyam is there. He want to listen. Then Shyam, what he will do? He will secretly stand somewhere. He'll hide himself, stand somewhere so that he is not visible to them. But in a live conversation only, he will be able to hear their conversation. That is the concept. He's secretly standing somewhere and he's listening their conversation live. Unauthorized real time. Are you able to understand? Please remember this example so that you can write it. But you can't give this Radha Krishna example only. I'm just telling you the story so that you can remember the concept and write the keywords. That is important. Real time interception of communication between the two parties over a network. Getting my point? That's what you mean by eavesdropping. Okay, we'll go to the next question. What is there? We have it. Arrange the following elements in ascending order using an insertion sort algorithm. So we have this insertion sort. So we have to arrange these elements using an insertion sort. So I'm going to teach you in a technique where accordingly they have given with respect to the textbook, with respect to the algorithm, what is there. That only I'm telling, not the swapping technique. You can write this. You can write this because representation wise they've given this only, but I am following what is actually given in the algorithm, so that no, you should not have any confusion between algorithm and this representation. Different should not be there, it should be the same. Okay, we'll do that. So I'm going to take up that. Okay, what is the number? The same number I have taken. Let me use the different color. No, I'm going to use this yellow, not yellow, red. 4, 3, 10, 1, minus 6, 2. Is it right? 4, 3, 10, 1, minus 6, 2. Yeah, it's right. Okay. So I'm going to take up with this in blue color. So I told you very clearly when I explained you this insertion sort in the model paper 1 only. So what is there in this insertion sort? Remember, there is a reverse comparison. Reverse comparison means what? There is a loop that is common. Let me write the loop here. 2 loop will be there. Which loop? Can you able to see this what I've written? Yes, you are able to see. 2 loops. One is going to be the I loop. I is equals to 0 to n. This is going to be common. And there will be another loop. What is the J loop? J loop is going to be from I minus 1 to n. I minus 1 to n. And what is happening? Swapping is not happening here. Shifting is happening. What is that shifting? T will be stored in L of j plus 1. And comparison, what about comparison? Ma'am, you are not telling about comparison only. What are you comparing? I am comparing this L of this stem should be less than L of j. This is comparison. And remember that I am telling you that it is a reverse comparison. Reverse, no ma'am. There is something called reverse. This is reverse and this is shifting. I'll just show you this shifting. This is shifting 1. This is shifting 1. Another shifting is L of j to L of j plus 1. This is another shifting. L of j to another L of j plus n. What about reverse? Reverse comparison means very simple. J is equals to j minus 1 and j will be decremented. J is equals to I minus 1. This is the first thing. And every time I decrement it, reversely will go, no? I comparing from this in a reverse way. Till where? Will you keep going? I can compare only till greater than equal to 0. J should always be greater than equal to 0. Only then it will work. Okay, so with this condition, I'm going to do it now. So what is that we will do now? So we have 4, 3, 10 and 1 minus 6 and 2. So I'm going to do it from the beginning. I is equal, so I'm going to do it from yellow color. Yellow. No, the next one I'm not going to tell. You will tell? No, I don't want to tell because I have own yellow dress. I don't want to tell that. I equal to 0 and here comes J. J is what, student? I minus 1. J is equals to minus 1. So I can't compare each one element at a time I'm taking. This is going to be my T. This is going to be my T. First element is that only. I can't compare with the previous elements. Ma'am, you told reverse comparison. I have to compare 4 with the previous element. Nothing is there in that. First comparison is not going to take place only. Loop is not going to run in this case. We will store this T. I'll just show you here. T will be stored in j plus 1. What is j plus 1? Minus 1 plus 1. That means L of, what is T? T is 4 only. No, 4 will be stored in 0. Same place it will be there. After that, I'm going to take up here. Okay, that's going to be 4, 3, 10, 1, minus 6, 2. So this is going to be my T now. 4, 3 I have compared. After comparing, T is less than 4, ma'am. 3 is less only, ma'am. You shifted. Shifting takes place. L of j will be shifted to L of j plus 1. L of j will be shifted to L of j plus 1. 4, 4, 10, 1 minus 6, 2. And this is going to be what? J is equals to, I is equals to 1 in this case. J becomes 0. j become minus 1 in this case. It does not satisfy the condition. Come out of the loop, and then what I have to do? Store this what? Store this t in L of 0. That means it will be 3, 4, 10, 1, minus 6, 2. This is going to be the condition. After this, I is equals to 2. What is I is equals to 2? I is equals to 2. In this case, I is equals to 2. Coffee. Thank you, sir. Abba, I'll take a break. I is equals to, so we'll just take up now. So I is equals to 2. In this case, I is equals to 2. So what is the value of j, students? J is equals to 1, because I minus 1, no. This is I minus 1. J should always be I minus 1. Hope you can see. Every time I'm decrementing. It was here, I shifted to this. It was here, it will be shifting like this. So now what happens? J is equals to 1. J is equals to 1, no. 0, 1, 2, correct. So this is my t. This is my t. Is temp greater than 4? Is temp greater than 4? No, ma'am, it is not greater. If it is not greater, come out of the loop. Just store this. What I have to store? 10 you store it in L of 1 plus 1. What is 1 plus 1? 2 only. Store 10 into 0, 1, 2. It is there only. Yes, because 10 is greater. No, it will not be shifting. It will be there only. Right? We'll go for the next. That's going to be I is equals to 3. What happens? 3, 4, 10, 1, minus 6, 2. This is going to be my t. Now, what is j? J is equals to 2. Compare 10 and 1. Definitely 1 is less than 10. Shifted. That means 3, 4, 10, 10, minus 6, 2. That's going to be j is equals to 1. See, you can just see here it became what? Minus 1 does not, loop does not exist. 0, from 0 it decremented. From 0 it became minus 1, decrementing the value. That's why j is equal to j minus 1. From 2 it became 1. From 1 it should become 0. Okay, now what will happen? Okay, I'll just have to compare here. 4 should be compared with 1. Okay, 1 is less. What I have to do? Shift it. That means what happens? 3, 4, 4, 10, minus 6, 2. What about this? J is equals to 0. Compare 0. That means L of 0. 3 you have to compare with t. T is equals to what? 1. 1 is less than 3. You shift it. Shift what? L of j to L of j plus 1. 3, 3, 4, 10, minus 6, 2. This is going to be the condition. What is I is equals to 4? J is equals to 3. I am going to write it. Okay. So what is my... Okay, this is going to be... I have written right only, no? Yeah, I have written right. Okay, 10 was there. So it will be minus 6. It will be t. So this will be t now. Correct, Alva? 0, 1, 2, 0, 1, 2, 3, yeah. After minus 6, yes. So after minus 6, then what happens? I have to compare with minus 6 and 10. It satisfies the condition. Minus 6 is less than 10. Shift it. So 0, 1, 2, 3, correct. So 3... No. After this, I just forgot, students. I just forgot here. After this, when the iteration ends here, store the value of t. What is t? T was 1. No, 1 you store it in L of minus 1. See, it becomes L of minus 1. Then only the loop stops. Minus 1 plus 1 means what? It's 0. L of 0. Store 1 in L of 0. That means this is going to be 1. 1, 3, 4. Okay, it's 1, 3, 4, and then it is have to shift it 10, 10, 2. What did I do it? 10, 10, 2, na? Yeah, it's right. Shifting only. Eraser. I'm going to erase this part. So it is going to 10, 10, 2. I have just shifted, very simple. 10 and minus 6 are compared. Minus 6 is less. What I have to do? L of j have to shift to L of j plus 1. The rest of the elements remain as it is. I'm not going to check that. After this 4 remain, 3 remain, 1 remained. After that j has to decrement. It's going to be 2 now. 2 means 4. 4 you compare with t, no? 4 you compare with t. Temp is less than, what is this? Temp should be less than L of j. Is temp less? Yes. T is what? Minus 6. Minus 6 less than 4. I have to shift it. 1, 3, 4, 4, 10, 2. After this, j is equals to 1. Compare this with t. What is t? T is equals to minus 6. Yes, 6 minus 6 is less. 1, 3, 3, 4, 10, 2. After this, j is equals to 0. 1 is compared with minus 6. Yes, t. Minus 6 means what? T only. No, it is same only. Minus 6 is less. Shift it. That means 1, 1, 3, 4, 10, 2. Okay. After this, j is equals to minus 1. It does not satisfy the condition. Store the value of minus 6 in L of minus 1 plus 1. That means store the value of 6 in L of 0. That means minus 6, 1 will remain as it is, 10 and 2. Is the point clear? This is going to be what? In this case, I'm going to take it as I is equals to 5. Then what happens? I'm going to do, take this is going to be t now. Compare it. Compare these two. I have to shift it. This is going to be j is equals to 4. Okay, shift it. 10, 10, 4, 3, 1, minus 6. J is equals to 3. That means what? I'm going to shift this, change it. 4 and t. T is what? 2 is less than 4. No, I have to shift it. Minus 6, 1, 3, 4, 10, 4, 4, sorry, 10. After this, j is equals to 2. That means 1 and 2 are compared. 1 and 2 are 1 and 2 or 3 or I think I have to compare 0, 1, 2. No, this I have to compare. 3 I have compared with 2. 3 I have compared with 2. Of course, 2 is less than 3. Shift it. Minus 6, 1, 3, 3, 4, 10. After this, I have to decrement the value of j. That means 1 is compared with 2. 1 is compared with 2. What will happen? 2 is not less than 1. It does not satisfy the condition. What you have to do? You have to stop the loop. This does not satisfy. What does not satisfy? That means to say that I'll just say this part. T does not satisfy L of j. What you have to do? You just have to shift it now. 2 you just shift it to. What is the value of j? J is equals to 1 plus 1. What is 1 plus 1? 1 plus 1 is 2 only. Store 2 in 2. Store 2 in 2. What is 2? 0, 1, 2. That means minus 6, 1, 2, 3, 4, 10. Okay, minus 6, 1, 2, 3, 4, 10. Oh, good that you're able to see it. Finally, what we got? Minus 6, 1, 2, 3, 4, 10. Okay, in one slide, no showing this, it becomes actually challenging. Okay, so we have sorted the elements. Very simple. In case of an insertion sort, we have to keep checking, comparing, just in a reverse direction and keep shifting it. Okay, swapping also can be done, but is not given in the algorithm that is there in the textbook. Okay, we'll go for this now. Okay, so what do we have now? So consider the temperature of 7 days of the week. This is 34, 34, 27, 38, 28, 34 and 34. Identify the appropriate statistical technique. Average you have to find out. Average is basically nothing but the mean only. Add everything and divide it by the total number of numbers what they have given. That's going to be what? By 6, so you're going to get 31.83 degrees Celsius. Range you have to find out which is going to be the highest temperature here. Highest is going to be 34 only, I think. 34 minus 27, it's going to give 7 degrees Celsius. That is going to be the range. And what do we have? Standard deviation. Hope you know the formula of standard deviation. So you need to apply properly with the proper numbers only, then you will be able to get it. So just check that. We have this root of 9.47, you're going to get 3. 0.08, and that is going to be the standard deviation value. Properly you need to follow this. See, formula remains the same, and only this numbers will be different. That's all. Application, everything is the same. Okay, we'll go with the next question now. Given the table name being a product, write the queries for the below functions. So what are the questions here? Like we have a P code name and then U price and then the manufacturer. Identify the primary key in the product table. What is the primary key? See, primary key should be unique. Definitely toothpaste cannot be same. This price also can be same. Manufacturer also we can't say. Dow, everything is same only. Okay, and then we need to go for P code only. Okay, product code I mean to say. So P code is the primary key. Alter the table. Okay, alter the table, identify the primary key in the product table, and you need to add the primary key here. Okay, so you need to add the primary key here. So how do you add the primary key? See here, you need to add the primary key after creating a table. Add the primary key after creating a table means alter table name, add primary key, space should be there, and give that primary key attribute name within the parenthesis. So P code I have to add, give within the parenthesis. Clear? And after that what you have to do, list the product code, select P code, product name, P name, U price, from table product, from product, order by, descending order. No, descending order means order by. Descending means what? DSC. Order by, P name, DSC. DSC means it's going to be descending order. Add a new column here called discount. That means alter table name, add discount, float 6,2. Float 6,2. Total number of digits, and this is going to be the digits after the decimal point. That means it should be 1, 2, 3, 4 point like this. Only this is going to be the total digits. 4, 5, 6, 2. Okay, total number of digits is 6, and 2 digits can be after the decimal point. That is the concept. Okay, calculate the value of the discount in the table product as 10% of the U price for all those products where the U price is more than 100. Whichever the U price is having more than 100, we are giving a discount of 10%. 10% is what? 10 divided by 100 into what is that? U price of that, right? So 10 divided by 100 means it's going to be 0.10 into U price, where U price is greater than 100. That means what I have to do? I have to calculate now. Very simple. Update. Whenever an update comes, set will come. Update product set discount is equals to U price into 0.10, where U price is greater than 100. Otherwise it's going to be 0. That means very simple. Update product set discount is equals to 0, where U price is less than or equals to 100. If it's greater, you give 10%, or else it's going to be 0 if it's going to be less than or equal to 100. Because clearly they said it's more than 100. So increase the price by 12% for all the products manufactured by Dow. So I need to increase the U price by 12%. That means what? Update product set U price is equals to U price plus 0.12. That's all. Okay, update product set U price is equals to, right, what I told. U price into 1.12, where manufacturer is equals to Dow. Is the point clear? Yeah, that's what I was telling you here. Increase the price by 12% for all the products manufactured by the Dow means you have to understand that you give 12% only. That is simple. 12 divided by 100 only you give it. Update product set U price is equals to 12%. But remember that only for this Dow product only, not for all the products. That means you need to give a where clause here, where manufacturer is equals to Dow, but Dow should be given within the quotes, because it's going to be a varchar or it's a character. Is the point clear? So that's all for the session. So we have done with all the questions for the model paper 2. Thank you. Please do post the comment, any kind of review, any kind of questions you have it. Please do post it so there is a scope for improvement. And thank you so much. We'll wind up the session. Thank you.